Swayam Prabha. Digital India. Educated India.
Now next let us go ahead and see what happens when I have a body with a line element oriented in an arbitrary direction maps on to a curve in the current configuration. That is, let me choose my basis Ex, Ey, Ez. I have the body, I have 2 points in the body, okay, one like this. Now this is in the reference configuration. Okay. Now I applied some force, I did something to the body, it got displaced and now it is occupying this position. Okay. Now the same particles are occupying these 2 points, okay, and that line has become a curve like this. Okay. So what happens is the straight line has deformed to a curve. Okay. Now let us say the direction of this straight line was initially A, okay, that is, if this makes an angle theta with respect to the x axis, A would be given by A is cos theta Ex plus sin theta Ey. Okay. So A is given by that expression. Now any point on the line would be given by S cos theta, S sin theta 0, because I am in the xy plane with 0 as the ordinate. This denotes the line AB, say this is AB. Okay. Now this curve line AB, okay, and here S varies from 0 to L, 0 to L ref, where this is length of the line okay. Now what happens, this deformed into a curve like this. Say I gave you the function, deformation field function, I gave psi as a function of x comma t. This deformation field is known. Field is known. Okay. Then what will you do to find the position of the particles in this curve? So x would be psi s cos theta Ex plus s sin theta Ey comma t, right. Now if I were to, what I have done, I have found x as psi of x s cos theta Ex plus s sin theta Ey. I am dropping the t because that is not of importance now. Y is psi of y, which is s cos theta Ex plus s sin theta E y, and z is psi of z s cos theta E x plus s sin theta E y. Okay. Now, if I were to find the deformed arc length, if I were to find this length, which will denote it by S current, okay. S current would be square root of dou x by dou theta, dou x by dou s the whole square plus dou y by dou s the whole square plus dou z by dou s the whole square ds, integrated from 0 to L ref, right, because s is the variable here, theta is a constant, that is how we represent a line. Okay. So, now I want to formally compute this in general. So, let us do that. Now, I have, what do I have? I have x, which is a function of x comma t to be written as x, some function of psi comma t. Okay. Now, I want to compute dou x by dou psi, which will be dou psi by dou x into dou x by dou psi. Okay. Now, this is nothing but dou x by dou x into dou x by dou psi. This quantity is nothing but your deformation gradient f times dou x by dou psi. Okay. So, what we have is the following relationship: dou x by dou psi is equal to f times dou x by dou psi. Okay. What this means is, it gives you the meaning of f. F is a linear function that maps tangent plane in the reference configuration to a tangent plane in the current configuration for the same curve. Okay. So, that is the meaning of the deformation gradient f. Okay. So, for a straight line, what is dou f? Dou capital X by dou psi, dou capital X by dou psi for straight line is it will be dou cap x by dou s, that will be cos theta E x plus sin theta E y, which is nothing but the direction A. Okay. So, now going back, this is nothing but dou x by dou psi, the magnitude of that. Okay. This entire thing under square root is dou x by dou psi, the magnitude of that integrated over ds. Okay. So, S current would be integral magnitude of dou x by dou psi d psi from psi 0 to psi n. This from our previous definition will be nothing but psi 0 to psi n magnitude of f times dou x by dou psi. From the definition of the deformation gradient, that is what it is. Okay. For this I can rewrite it as psi 0 to psi n square root of f times dou x by dou psi dotted with f times dou x by dou psi d psi. We have already seen that if I have A dotted with B times C, this is nothing but B transpose A dot with C, okay. Hence S current would be integral psi 0 to psi n square root of f transpose f dou x by dou psi dotted with dou x by dou psi d psi. This is psi 0 to psi n square root of c times A dot with A d psi, where c is nothing but f transpose f. This is the right Cauchy Green deformation tensor. Okay. And here I have replaced dou x by dou psi to be A, because I considered, because in the reference configuration we considered a straight line. Okay. So, this is the current arc length of the curve in the current configuration. So, we are interested in the such ratio lambda along a direction A, which is S current by S reference, which will be, in our case it will be integral psi 0 to psi n square root of C A dot with A d psi divided by integral psi 0 to psi n A dot with A d psi. Okay. We will stop here for today's lecture. In the next lecture we will simplify it and get the linearized strain tensor from here. Okay. Thank you.